See, and after that we'll still move towards next point. What is IPC basically? Process is a program in execution. Whenever a programmer will execute that program becomes process. If two processes are depends on each other, in that case, the programmer or two process must have communication between two processes if there is a dependency. In that case, communication is must between these two processes. Suppose this we have these two process P1 and process P2, and there is some dependency between these two processes. So suppose process P1 wants to communicate with process P2, or process P2 wants to communicate with process P1. At that time, communication is required. That communication can be done with the help of IPC. IPC is nothing but inter-process communication. Okay. So whenever process is a dependent process, or this dependent process is also known as cooperative process, in that case, inter-process communication is very much needed. Okay. So we can see here the process executing the concurrently in our operating system may be either independent process or cooperating process. Okay. This process is independent if it cannot affect or affected by the other process executing in the system. Any process that does not share the data with other process, that is independent, because they are not sharing anything. Dependency is not there. So such type of process is known as independent process. And a process is cooperating if it can affect or to be affected by other process executing in the system. Such type of process is not known as cooperating process. So what are the reasons which are available because of that communication is required? First is information sharing. The resources are sharing information. At the time, communication is required because there is some amount of sharing is there. Several users may be interested in the same piece of information. So in such a case, information sharing is available. Second is computational speed up. Suppose we want a particular task to run faster. Because of that, we are dividing a program. We are dividing a process into number of sub-process. Because of that, the parallel execution of the task that can be done, and this may speed up the execution, but for this communication is required. We must break the task into subtasks, and each of which will be executing in parallel with others. Such speed up can be achieved only if the computers have multiple processing cores. Next reason is modularity. What is modularity? If we we want to construct a system in modular fashion, dividing a system function into separate process or thread. Thread is nothing but the few part of a process or subtask of a process. And last is convenience. Each and individual user may work on a many tasks at the same time. So for convenience use also, communication is required. So what are the cooperating process? Cooperating process require IPC, and IPC mechanism is of two models. First is shared memory and second is message passing. First we'll see what is there in shared memory. In shared memory, suppose this is a your OS. In OS, suppose this is your process P1. This is a shared memory. So I am writing shared memory with SM short form. This is process P2. And at last kernel is there. Okay. What is there in shared memory? What is there in shared memory? Suppose process P1 wants to share something with a process P2. At that time, process P2, sorry, at that time, process P1 can write something into shared memory. Okay. Now, process P2 wants to update something at that time. Before updating, process P2 read the data which are available in shared memory, and after that do the modification. This is a concept of shared memory, and at last kernel is there. This is what somewhat similar to sharing a Google Docs in between person. And so that they can update the document, and before updating the further information, another reader or another editor will see the content which are available in the Google shared sheet, and after that he make a decision, and after that only he perform assignment or perform operation on that. This is a concept of shared memory. Next is message passing. So see here, this is a diagram. What is there in message passing? In message passing, see, process A wants to send a message to process B. At that time, process A sends a message to process B. Okay, this is directly process A can send a message to process B. Suppose the because of few reason the message is not sent to the process B at that time. Message is there in a message queue, and when process B got that message and he want to reply something, then only process B can send a message to process A. So this is a model of a message passing. So what are the mechanism which are available for IPC? First is signals. Second is first in first out, that is a pipe, name pipes. Third is next is pipes, sockets, message passing, shared memory, semaphore. These are the few mechanisms because of it inter-process communication that can be done. First is pipe. Pipe is a communication between two or more related or interrelated process. Okay, and it can either within a one process or communication between child and parent process. So this is what one process that want to write something at one end. Okay, he will write at the one end of a pipe. Okay, and second process that want to read something, and so at the another end, that's another process that read the content which is written by the process P1. Suppose this is a parent process on left hand side, and this is a child process which is reading the content which are written by the parent process. A process can send the data down a pipe using a write system call. And for writing a content, write system call is there. And for reading a content, read system call is there. Now see how the programming within a pipes that can be handled. Within a programming, pipe is created using a system call. The name of system call is pipe. So suppose when you want to implement a pipe communication for the IPC, at that time you have to call a pipe system call, and this system call would created pipe using a one-way communication. One-way communication means what? At one way only, suppose at one end it is only possible to write something, at that time another end is there for reading something. Suppose first end is there for the reading, at that time end is there for the writing. At a time we cannot read, or at a time we cannot write from the one end. So this would return a 0 on a success and -1 of a failure. Suppose in after using a pipe system call, you are getting -1 as output. That means what? The communication, IPC communication is not done with the help of IPC. Because of that, you are getting a error as a -1. And suppose you are getting a return value as a 0. That means what? Successfully communication done between child and process. So see which header file is required for this communication. UniSTD, and this is a pipe system call. Inside this pipe system call, we are writing a file descriptor 2. 2 is a number which denote 0 is if it is written as a 0, that means what? Successful communication is done. And here in file descriptor it is written as a -1, that means what? It is a failure of a system call. This is what? Implementation by using a pipe system call. File this is a two-way integer array that will hold the file descriptor and identify pipe is successful or not. If file descriptor is 0, that means what? Reading from the pipe. It will be open from the or reading from the pipe, and file descriptor 1 means what? It is open for writing down it. If pipe can fail, it return a -1 and cannot obtain the file descriptor. Okay. So this is what? Implementation indication of a file pipe system call. How you are going to close a file descriptor by using a close function. Okay. Now see, the read from the pipe only gives the end of a file. If all the file descriptor for the right end, the pipe have been closed, and thus after a fork system call, whichever a process is intending to do the reading has the best close, and that can be written by using a close system call or by using a close function. So how the programming that writing programming that can be done in a pipes. For this write function is there, and this is file descriptor one is there for the writing a file system call, and string and max, that is the size of the write system call. That is a size of a string function, size of a string data type. And this system call is write the specified file with the argument of a file descriptor. FD is nothing but the file descriptor, and this is size of a buffer. And the file descriptor ID is to identify the respective file which is written after calling a pipe system call. The file needs to be open before writing the file, and it must be open before writing, and it automatically opens in case of calling a pipe system call. Whenever you are calling a pipe system call, it will automatically open the file and it is able to write the things by using a write system call. And this call would return the number of bytes written or 0 in case of nothing is written. On a success, and -1 in case of a failure, and proper error number is set in a case of failure. Now see, next is what? Programming with pipes. File descriptor 0 is there for the read inline, and line and max for the buffer size. Now that was a one-way communication using a pipe. Second is what? Two-way communication using a pipe. This is a pipe one. This is a parent process. This is a child process. This is, suppose this system call is writing from this end. So another system call that can read from the another system call. Suppose uh, the same pipe is there, or we can say the next pipe is pipe 2. At that time, suppose parent process is reading from the one end. At that time, child process can write the content from the other end. This is a two-way communication using a pipe. The pipe communication is viewed as only one-way communication. That is either a parent process writes and child process reads, or vice versa, but not both at a time. However, what if the both parent and child needs to write and read from the pipe simultaneously? The solution is two-way communication using a pipes. The two pipes are required to establish a two-way communication. Next is what? Process management. How the IPC that can be implemented in your lab. So this is what? Write a program to implement a pipe or shared memory concept. For this you have to use an algorithm. What is the algorithm? You have to create a pipe using pipe system call. Okay. In a parent process. This is the first task. Second is what? Create a process using a fork system call which return a 0 to child process and some non-zero positive number to a parent process. That means what? Successfully child process is created. Then you have to write a message and transfer them from the pipe in a parent process. After receiving a message, the child can read the message, and whatever the child can read, that can be printed the same message on a console. And you have to use a wait system call to collect the status of a child process. Once the execution of child process is done, you have to use a wait system call to kill a child process, and at last you have to terminate a parent process. So this is a program by using which you can implement a IPC using a pipe process. Okay. Next is process management. That is a thread. Thread is a part of a program, or it is a lightweight process, and it is an execution unit within a process. All the threads of same process share the same address space. Thread can share a same address space of a process because suppose process is divided into number of subtasks, that one subtask is considered as a thread. So thread can share the same address space. The all thread have separate stack and individual thread ID. Everyone has their own thread ID. Okay. And thread is a lightweight process because the context switching between the two thread is inexpensive in terms of memory and resources. Multi-threading is what? It is an ability of operating system to support multiple concurrent paths of execution within a single process. And it is also described as an interleaved execution of a thread. So see the difference between process and thread. Process is a program in execution, whereas thread is a part of a process. So suppose this is your one process that divided into number of thread. So this is suppose your one thread, this is another thread, this is your third thread. So we can say that the thread is a part of a process. The process has its own process ID and thread is having their own thread ID for the identification purpose. Every process has their own memory space because initially process is created at that time. So few amount of memories are assigned for that process. Once the process has their own memory, and when the process have the few part of a process as a thread, so it's not required to have a separate memory for the thread. IPC is a slow because they need a few part of a communication mechanism for the communication between IPC, but inter-thread communication for the thread within the same process is faster. The context switching is expensive in terms of IPC, but in case of thread, context switching is not expensive in terms of memory and resources because thread can easily communicate with each other and they are sharing the address space of a process. So as compared to process, it is not expensive. So this is a difference between process and thread. Now see the diagram. This is diagram for thread. This is single threaded model. What is there in single threaded process? Every process has their own code, own data, and files. Code means what? Programming code or execution code. Data means what? What are the things which are related with that data that are available? Whatever input variables, what is a local variable, what are the global variable, what are the data that are available for the process, and files is what? Whatever files which are required for the execution of that particular process that are available there. And this is a one thread, and this thread is having their own register. What are the different types of register? Registers mean program counter register, data register, address register, buffer register. So execution of this thread, which will be the next thread that can be executed. All this information that can be shared in the registers. And thread is having their own stack. Okay. So this is a structure of a single threaded process. Next is what? Multi-threaded process. What is there in multi-threaded process? See here, process having their code, data, and files. And these are three threads. These three threads have their own registers. They are having their own stacks. This is threads and registers there for the first thread. This is registers and stacks for the second thread. These are the registers and stacks for the third thread. So this is a multi-threaded process. Now see the diagram. This is one thread, one process. This is a one process and this is one process and multiple threads. This is multiple process with one thread per process and these are multiple process and multiple thread diagram. What is multi-threading? Operating system supports multiple threads of execution within a single process. Example, MS-DOS supports a single thread. Unix supports a multiple user process but only supports one thread per process. So thread base is what? Each thread is having their own thread ID, set of registers, stacks for local variable and return address, and priority. Okay. And what is common? Process instruction is common, data is common, files are common, signals are four commons, user and group ID is common, and current working directory is common for the all threads. So what are the various states of a thread? First state is new state. When process is about to create, at that time, process is in new state. Second is ready state. When thread is ready for the execution, at that time, thread is there in a ready state. Next is running. When process is started the execution, at that time we can say that, when thread is started the execution, at that time we can say that thread is being executed. Next is waiting and block. When thread is waiting for the event or a resources, at that time thread goes under a waiting state or a block state. When the thread completes its execution, we can say that it is terminated or it's in exit state. What are the benefits using a thread? First, it improves the performance of a system. It is having a faster context switching. Resource sharing is available in a thread. Responsiveness is available, and better resource utilization is available because of that. These are the threads are very useful. What are the different types of thread? First type is a kernel level thread, and second is a user level thread. Kernel level thread is available in a kernel space, and user level thread is available in a user space. So what is there in user level thread? The user level thread are implemented using user or a kernel that is not aware implemented in user, and kernel is not aware about the threads. The kernel handles them as if they were single threaded process. User threads are much faster than a kernel thread. It is represented by using a program counter. User thread have their PC, stacks, register, small process and process control block. And there is no kernel involvement in a synchronization for user because it's available in user space. So there is no involvement of a kernel available, and user threads are managed entirely by the user level library only. What are the advantage of user level thread? First advantage is user level thread are easier and faster to create than a kernel level thread, and they can be more easily manageable. User level threads can run on a operating system, and there is no kernel mode or privilege required for the thread switching because switching that can be done in a user mode only. What are the disadvantage? Multi-threaded application in a user level thread cannot use the multi-programming to their advantage, and entire process is blocked if one user level thread perform a blocking operation. So these are the disadvantage and advantage using a user level thread. So next is what kernel level thread. What is there in kernel level thread? Kernel level threads, these are handled by the OS directly. So, and it is handled in a kernel mode only. And the thread management is done by the kernel only. The context information for the process as well as the process thread is only managed by the kernel only. Because the kernel level threads are slower than the user level thread. So what are the advantage and disadvantage? First advantage is that multiple thread of the same process can be scheduled on a different process in a kernel level thread. Kernel routines can also be multi-threaded. If the kernel thread is if one of the thread of a kernel is blocked, the same process can be scheduled by the kernel. So these are the advantage of a kernel level thread. Second is disadvantage. A mode switch to kernel mode is required to transfer the control from the one thread to another in a process, and kernel level thread are slower to create as well as manage as compared to user level thread. So these are the advantage and disadvantage by using a kernel level thread. So next thread is POSIX thread, that is a portable operating system interface standard. This is a thread function. So here pthread create function is there for the creating a new thread. Pthread exit function is there for termination of the thread. Pthread join is there for the suspend execution of a calling thread until the target thread is terminated. Pthread self is there for the self function returns ID of a calling function, and pthread detach function is there for the detach of the function threads. So these are the basic functions which are available. So next is process scheduling. Just